start. The two announcements. So I hope you're having a great day. I haven't had a very good day, as you might imagine if you've tried to use Sage Math Cloud in the last 2 days. There's some very serious problems that I've been working hard on. As a result, you can turn in your homework on Monday rather than today. So if you're having trouble, just wait. Or rather, don't worry about making sure you're finished by the end of today. You may want to take a little of the weekend to maybe learn more Python if you don't know Python as well, since I'm obviously not covering everything. The main things I'm going to talk about are dictionaries and classes. So that's what we'll talk about today and try out. And should have enough time to do that. So let me zoom in a little so you can see this. I talked super briefly about tuples last time, and I'll come back to them for a moment. But first, let's talk about Python dictionaries, which kind of motivate tuples a little bit, actually. So a Python dictionary, there's a lot of names for it in other programming languages, but it's the idea of a thing that maps from some domain to some codomain. I very, very, very briefly at the end told you about these last time. So here's an example of a Python dictionary, which I've called D. And when you print it out, and again, we made the same one last time, notice that it doesn't look exactly like what I typed in that the order is different. So in a Python dictionary, there's no particular order to the keys of the dictionary, as they're called. One thing, though, is that they have to be unique. So if you give the same key with 2 different values, it'll just ignore one of the values. So notice that 3:8 just got completely ignored. Just like a function, for each input, there's exactly one output. There aren't multiple outputs for the same input. And by function, I mean a function in the sense of mathematics, not in the sense of computer programming languages. Where, again, because you're mostly math majors, I should point out that Python functions aren't necessarily functions in the sense of mathematics. Just because, for example, here's a Python function, and it returns a different thing for the same input. So if I give it 5, and I give it say 5 again, so I give it 5. Oh, what? F not defined. Oh, because I called it foo. If I give it 5 and I give it 5 again, I get a different value. So despite being a function, it's not a function in the sense of mathematics, which is kind of just important to keep in mind. That is, when you call it at a different point in time, it might just give you the exact same thing, gives you back different values. Likewise, dictionaries, because they can change, at a given point in time, you can think of it as being like a function, but you can change values in the dictionary. So here, for example, I could change 10 to, I'll just change it to foobar. And now, if I do D10, it gives me foobar, whereas before, if I did D10, it would give, before if I evaluate this, and then I do D10, it gives 100. And then you change it, and now it gives you foobar. Oh, and by the way, if you give an input that isn't there, it gives you an error. And the key error is, key error 7. Just like in other languages, you can catch these exceptions, as they're called. I don't want to do a lot with catching exceptions, though I could. But here's an example. Try do that except key error, and if that happens, print an error. There was an error. And then you can do anything you want here. It's just some code. See? There are a number of subtleties to these try except blocks. The things to note are, first, it's Python, and so everything kind of looks the same. It's a keyword, and then a colon, and then everything's indented. And everything inside of that block, if any of these exceptions, like this kind of error appears, this code that's after except will get run. More precisely, you say except, then you give a specific exception. You can also give a tuple of exceptions, and you have to be careful with that, though. And then this code that's indented gets run. Okay? So you should learn more about try except by searching online. There's a site called Code Academy, which is a very good place to learn the basics of Python if you don't know them. All right. So I may have mentioned tuples very quickly last time. Well, yeah, I definitely mentioned them very quickly last time. They are like lists in that a tuple is an ordered collection of Python objects. But you can't change what Python objects are being you can't change what Python objects you're considering. You can change the objects themselves, like what's inside of them, but you can't change which objects your tuple gives you. So there's some chance that a tuple can be immutable in the sense that it can't be changed. In Python, this idea of immutable is it's extremely important because for a dictionary, the keys have to be immutable. This is not sort of an a priori requirement for the idea of a dictionary as a data structure. It's simply an implementation detail to make them more efficient. But if you don't know about them, then you could get very frustrated. Let me show you how you could get very frustrated. Let's say you're excited because you learn about dictionaries, and you want to make a dictionary D, and one of the keys is 5, and the other key is the point 2, 3. Well, it's a list 2, 3. And you're representing your points as a list 2, 3. So a list of length 2, have 2 things in it. And then there's some corresponding value. This is not going to work. The reason it won't work is because for a Python dictionary, each of the keys has to have a hash method. And lists don't have a hash method. It turns out, under the hood, Python dictionaries are implemented via a hash table. And you don't want to make it so that objects have a hash, but the objects can be changed. If it were possible to hash 2, 3, then that would be very bad because a hash, you might come up with some number that's a hash of 2, 3. And then what if somebody just changes this list, like changes the 2 to a 7, which you can just do? Then the hash would still be the original hash, at least as it's stored here. So first, let's get an error when we try to do this. And this is just to motivate the fix. Notice it says unhashable type list. So the reason, again, is that dictionaries, the keys have to be hashable. And things that are hashable can't change. So if you compute the hash of them and they change, then your hash table gets all messed up. Because when you search for the object, the hash has changed, so you think it's not there, but it is there, basically. Again, though, this is an implementation choice. They could have made Python dictionaries work fine with hashable keys, with non-hashable keys. Your keys could have been all mutable and whatever. But then in order to look up a particular thing in the dictionary, in order to do d x, where say x is equal to 2, 3, if you were to do that, it would have to compare each of the keys in the dictionary to 2, 3, one by one, and see whether or not it's equal, and then give you back the corresponding value. That may seem like a completely reasonable thing to do, because 2, 3 is really small, and there's only 2 keys in this dictionary. But imagine a dictionary with 100,000 things in it, and imagine that your keys are a lot more complicated to compare. Suddenly you start ending up with code that's very, very slow. So to somehow basically force you to write code that at least is reasonably fast, in Python the keys have to be hashable. That is, there has to be a hash method that's defined on them. So here we are. So if instead of using 2, 3 the list, you use 2, 3 the tuple, so notice hash of 2, 3 doesn't work. But if you use 2, 3 the tuple, a tuple, again, is like a list, but you use parentheses when you're defining it. And you're not allowed to change what Python objects are in that thing. You can change what's there, but as long as each of the entries in the tuple is itself hashable, that is, it can't be changed, then the whole tuple will be hashable. There's a formula for the hash of a tuple in terms of the hashes of the individual entries. And then you can use W, in this particular case, as a key to a dictionary. And look, right here we're making a dictionary where instead of lists in square brackets, those very convenient but very mutatable objects, we've used tuples in parentheses. And this works perfectly fine. And if there were hundreds of thousands of these tuples as input, you could still quickly check to see whether or not something's in here, or you can look up the corresponding value. Because hash tables can get used behind the scenes to make things very fast. And this basic data structure of a dictionary or a hash table, this is something that in Python it's been optimized over 20 years, a huge amount. Like if you look at release notes to Python over the years, very often it's like we implemented some clever low-level trick to make dictionaries faster. Now everything's 10% faster. And a lot of other things in Python, like Python classes that model more complicated things, are built up on Python dictionaries. They're like the basic data structure on which a huge amount of Python is built. Okay, so you can use anything immutable as the keys. As we'll see in a moment, though, you can make your own class, and you can define a hash method for your class. And nothing forces you to make the class itself immutable. So it's really kind of a convention, the way this works. You could, as I did for the first few months when I was writing Sage, stupidly, you could... Just distracted, my phone's buzzing. You could stupidly create classes that are immutable. An example might be a class that represents a matrix, right, where you can change the entries. And you really, really want to have matrices as keys in dictionaries for some reason. Maybe, I don't know, I mean, I can think of reasons you want to do that. And so what you end up doing is having a function that computes the hash of the matrix. Maybe it's somehow a function of the hash of all the entries of the matrix. And you do this, and then you end up with all these nice dictionaries all over the place that involve having a hash of matrices, but also you can change the entries in a matrix. Like when you compute the echelon form of a matrix, you do all kinds of manipulation to the matrix. And so then you end up with all these dictionaries all over the place, and then lots and lots of subtle bugs because they don't work the way they're supposed to work, because they assume that objects are immutable, that the keys are immutable, but in fact your keys are mutable. So watch out. Actually, I'll show you that in a minute if we have time, which I'm talking so quickly we will, maybe. Okay, one other example with tuples, and then we'll move on to, well, an exercise, and then we'll talk about Python classes. So this is just to emphasize something I've already said to you a few moments ago. This is a Python tuple. It has two entries in it. The first is the list 2, 3, and the second is the number 5. So as a tuple, the Python objects that it points to, they don't change. They're the same objects. And it's always going to point to two things. But the first entry just happens to be mutatable. It's a list. You can change what's in it. So hash of W doesn't work. So tuples they're not always immutable. Sometimes they are, sometimes they aren't. It depends what's inside of them. So hash of W, it doesn't work. The reason is because the first entry can't be hashed. And look, you can also change it. So here's an example where I take the first entry, W square bracket 0, and append the word sage to it. And suddenly my tuple has its first entry 2, 3 sage, and the second entry 5. So it's changed. Okay? And let me evaluate this and just emphasize what's going on here. ID of W0. This is the memory location. So the point it's like a pointer to, in memory, this object. And then we'll change that object, that list. And it's now changed because we did the append. But the ID of W0 is still the same. See? It's exactly the same. By the way, when I evaluated and it skipped down, that was kind of annoying. If you do Alt or Command instead of, if you do Command return or Alt return instead of Shift return, then it doesn't move, just in case you're curious. So notice these two are the same. So W, it's a tuple. It points to the same objects, but those objects themselves can change. Okay, so here's an exercise for you to do. I just give a list of a couple of things. Just figure out which ones are mutable and which ones aren't. And in your head, make sure it makes sense. So which of the following are immutable? String, list, number, etc. And then make a dictionary that has as keys exactly the mutable objects. You can make any values up you want. And note that the values in a dictionary, they don't have to be immutable. So they can be changeable. That's fine. So just right now, in a copy of the Sage worksheet that you have in front of you, and I'll walk around, just decide which of these things are immutable and which aren't. So A, you can think in your head, should this object be something that can change or not? If not, then it should be immutable. But second, you can test for immutability by just going hash, H-A-S-H, of the object. And to get you started, you might think, a string. A string is probably not is probably immutable. Although, again, it's just a design decision. In some languages like C, strings are mutable, but in Python, they're not. And so you can check whether your guess is right by doing hash of the string. And if it gives you an error, that means it's mutable. If it doesn't give you an error, that means it's immutable and can be used as a key in a dictionary. Okay, so this no error, that's if and only if it's immutable. And in every case, it's really a design decision by the Python developers whether things are immutable or not. It's not sort of a God-given thing. And you can find each choice of design decision if you look hard enough at various languages. I mean, there aren't infinitely many languages, but you can find somebody wanting to make a language of these sort of choice. That's why writing programming languages is so hard, because you suddenly discover there's like 2 to the n choices for a very large value of n. Okay, so do this, and let me know if you have any trouble. I remember, if you see a big error, that's good. That just tells you that something's mutable. Doesn't mean something bad happened. There's no the output is a safe version. Yeah. No. So we appreciated a lot of it. Well, it shouldn't. It should never happen. But it's funny because it might have been an example where basically
Both are fine except the string.
where we check potentially old clients that are just trying to write the same thing over and over again. Except apparently it's writing out something not there in some cases. So therefore, like, you have some patch. Oh yeah, I did. Yeah, I disabled that. Well, actually, we went in so it's not going to happen. Yeah, okay, let's see. Okay, because when I tried it, I was like, you had 4,000. So you made a set, not a dictionary. Maybe I should set that. So this guy had a really interesting comment. He took his, like if you're like, oh cool, foo is mutable, let's make my dictionary. Let's see, I'll just do two of them, 3.4. These are both immutable, so I'll make my dictionary. Woohoo! But what did I do wrong there? Yeah, it's not actually not a dictionary. You could say type of D, and it's a set. So there's another data structure in Python called a set, which we hadn't talked about yet, which the notation is literally like a set in math. So don't get confused. This is not a, let's write that, not a dictionary. So what you want to do is make a dictionary. You have to give some values. Okay? Actually, probably everybody's done by now. So any questions about this? So actually, his second question was, after you make your dictionary, he, for some reason, wanted to hash it. Actually, no, it is a dictionary. So now he wanted to hash his dictionary to check that it was right. So he did hash of D, and it gives you unhashable. So is this reasonable that you get an error when you hash D? Why is that reasonable?
Mutable.
Why is this? Based on other things, why should this be mutable? Yes?
Because you can change what each
Yeah.
value is assigned.
Exactly. What if I change the 1, 2 to be parentheses 1, 2? That's a dictionary. Everything's fine. What's going to happen when I try to hash that? Error, or is it going to work? Noting that 1, 2 is immutable, 5 is immutable. Like all the things in defining my dictionary are immutable. Do you think this should work or not? Why shouldn't it not work? Literally just say your same answer again.
You can still change the values.
Yeah, exactly. You can still change the values. Like you can't literally change the values themselves, but you can change what the values are. Like you could, there's no dictionaries at all that are immutable. All dictionaries are mutable. Okay? Any other questions or comments? All right, on to classes. To motivate classes, I've defined a function called length, and that takes as input one thing, self, and then I defined a dictionary self, which has three things: x, 10, y is 5, and I put as one of the entries in my dictionary this very function. Okay, so I evaluate that. To show you it's live, maybe I'll change something slightly. And then evaluate this, and it works. And so if you imagine what I just did, you could build up a notion of points this way, where a point is a dictionary with an x and a y, and then you could have various functions that operate on a point and make those attributes as well. And whenever you want to call one of those functions, you just look it up in the dictionary and then call it on the thing. Obviously, this could get really tedious. See, even saying the word is hard. So let's do something better. So the above would be very, very awkward. Python classes let you accomplish the same thing, and it's really, really, really clean and nice. So here we are. This is a Python class, and I'll just talk through the whole thing, and then we'll try it out, and then we'll do an exercise involving it, and then we'll be done. So the notation, or syntax in Python for defining a class is basically as simple and clean as you could possibly imagine, unlike, say, Java. And it looks very much like everything else in Python. The keyword is class. So you say class, then you give the class a name, and then you put a colon. Again, it's like everything in Python. Keyword, something, colon. And then you indent, and everything that defines the class just goes indented, just like everything else in Python. And now the first thing is we can give various methods. That's all I'm going to do here. You can name the methods any valid identifier. The ones with double underscores, that's what these really long things that don't look like a double underscore are. There's actually 2 underscores in a row right there. It's maybe hard to see that unless I put the cursor right in the middle. These are called dunder methods, and there's a long list of dozens and dozens of these dunder methods. And what they do is they let you do things like operator overloading and customize how your class instances print. For example, dunder repper, by defining this method, whenever you try to print out a vector, it'll print by saying the vector blah. So you can specify exactly how you want your things to print. And this one, dunder add, if you ever have two vectors, x and y, and you say x plus y, like use the plus sign, then it will call dunder add on those two vectors. And the one at the top, underscore underscore init, underscore underscore, anytime you create a vector, it will call this special method, this dunder method. Okay? So you don't have to give any of those, but it's a good idea to do so. And it just makes your usability of your class better. And then just like above, remember before I made a function called length and then made it one of the values in the dictionary. Here what you do is you define a function length that takes as input self. So self is an instance of this class. And what it'll do is it will return the square root of the sum of the squares of the x and y components of self. So I'm kind of doing this in random order. And then finally, whenever you make a vector, and again I have to show you below how you would actually do this, what it will do is it will call this function init, and you can do whatever you want here, and I'm doing something really simple. I just set the x, this is like setting the key x to have the value x, and the key y to have the value y. Though the notation's a little cleaner and simpler. Under the hood, each instance of a class actually has a dictionary associated to it, and then there's just this nice notation that makes it easier to use. Things will be a little clearer once I show you using this dictionary. Using this class. Let's see. Just kind of want to put more on the screen at once. So full screening it, and then I'm going to split the screen, hopefully. And I'll make the top smaller so you can see it. Maybe so you can't see it. Then I'll delete my white space. Okay, so there's our class, and now let's use our class down here. And I'll make that bigger. Okay, so again, this is something where in every programming language it's slightly different. And basically Python has the simplest possible choice. So here's how you make an instance of the vector class. You just say v equals vector, and then you give some defining properties of that vector, some defining data for that vector. This stuff will just get passed into the init method, and then you get back some object. Under the hood, behind the scenes, there's a dictionary that records that data, and that object also has each of the listed things that you've defined here, plus some other stuff that's built in, as methods. And if you try to do things like call them, it will work, and you can do addition and so on. This is really nice and clean. You don't have to put new in front of vector like you would in JavaScript, and there's other things you don't have to put here. It's really just kind of the simplest, cleanest thing you can hope for. Well, it's pretty simple. There's nothing. Just do it. No keywords, nothing. Okay, so let's try it out. So I'm going to define vector up here, and then down here, well, I'm not really saving very much by splitting the screen, am I? But let's see. I'll make it pi and e, make it a little more exciting. And there it is. And then I can ask for the length, and I can add the vector to itself, and that calls this add method, and so on. And you can just put whatever code you want in each of these. Remember I mentioned that there's a dictionary behind the scenes? It's called _dict _. Okay, look. So really, a Python class, it's like what you would get if you decided to build your own way of having classes on top of dictionaries, and then kind of added a whole bunch of language stuff, and then cleaned it up repeatedly over the years. And it also supports some really interesting things like inheritance. So if you want to make a general class that's vector and then want to derive from it some sort of special type of vector, you can do that. And in Python, you also have multiple inheritance. So you can have a whole bunch of classes and have a single class that's derives from all of them. Okay, so it's a full object-oriented language where you can do all kinds of stuff like this. And just to sort of give you a feel, so you can, inside of a method, you could do, hi, this is length. And up here we could do, I just initialized myself. So you can change the class a little bit. And then down here, when you call these things, assuming, okay, tell me why that didn't work. The only thing I evaluated was v.length. Why did it not print that thing up there?
You didn't evaluate that first.
Exactly. I did reevaluate this, but I didn't reevaluate this. So in fact, it was using the old vector, which was created using the old code. So I need to reevaluate this right here to create a vector using the new code, which I've now done. And now it prints out that extra little bit. Okay? So there are lots and lots of other, I'm just going to kind of put this right here and then put the exercise, which you're going to do now. You can add other methods. If you search online for something like special methods or dunder methods for Python, you can find out about lots and lots of other ones like mul, div, etc., which you can define. So make your own class, but for a 3D vector rather than a 2D vector. Okay, all you have to do is copy and paste this code, and instead of x and y, you have x, y, and z. And the length function, you'll have self.z squared as well. And you might want to change, like maybe instead of the vector blah, you could say like Williams vector blah or something. So you could customize it to yourself. If you're done with that, you could add another method, cross product. So def cross product self comma other, and then you would pass in another vector. So you do something like v dot cross product, and then give another vector w, and then it would return the number, which is the cross product of v and w. Okay, so make your own three-dimensional vector class, starting with this two-dimensional vector class and changing it, and then try it out and add some methods to it and modify these methods. Okay? And we have like 10 minutes.
What's the last method do?
Repr. So the last method customizes how it prints. So if I wanted it to say Williams vector, then I can reevaluate this code, then I also have to redefine v. But now it prints as Williams vector. So you can make things print however you want. This notation, which I've never talked about before, is called string interpolation. You give a string, and then you put %s's in, and you say %, and then you give a tuple, and it slots in the first %s gets the first thing in the tuple, the second %s is replaced by the second thing in the tuple, etc. Okay. Yes?
Do you want us to do this in our own projects or in the shared?
Do it in your own project, and then you can paste it into the shared one if you want. I'll pull up the shared one to see what insanity is occurring there. So nobody has it open now, but if you successfully open the shared project and want to paste in something, hey, look, somebody lay lifted. So feel free to paste in whatever solution you have here. I'll make it small so that other people can see them. Okay? And of course, if you have any questions, just let me know. Yep.
I think that's in
Actually, in Python, that would be okay. In Sage, that should work. That said, you really want to take this through, but you can do whatever you want. Yes, it should work.
Space.
You can also use a query in Sage.
Okay. What you use is like the second fraction or something for the query.
yeah, you definitely otherwise it would raise it to the power of 1 and then divide it by 3. Would be the boundary. Do you like cross product process? Sweet. Can you paste it into this? Add a cross product process. Further challenge. Significant. Yes. I'm sure it's going to start the that's exactly how we did it. That's actually it. Yeah, because you're trying to return wrong side. And it's hard to, it's actually really subtle. Whatever you want, whatever is on the way. You can do lots of things. You should follow it. Yeah. Is this exactly. It's another thing. And you can even do like, if you have a vector string plus anything at all, it'll pull that as with another rock. So this will only, it'll just give you it'll just explode it. It doesn't actually. That's so much. Yeah, well, all of it. It's almost yeah, it's good. Well, you don't need to do it. Just try to see. It'll just give you an attachment. It does properly. No, I think it's this there. It says you can also use this instance if you wanted to check out how you use it, not this instance with vector 3 and make the vector 3. Oh yes. Is it always like this, or is it? Or is it? Okay. Then it's Yeah. This is a problem. It's actually where it says percent essence 3. Oh, right. Yeah, make sure you evaluate this. Like we had this. So we're almost done. I want to tell you what by far the most common mistake is in translating this code. So what people do is they take the code and copy it, and they change the name of the class to vector3, and then they change some other stuff here, like they add a z, but then they don't change this vector to vector3. And the result is that when it tries to add two of them, it tries to call the old vector class rather than the new one that you just made. So it's very important to change, when you're making the 3 version, to change that to a 3 right there. Okay? And I think that was literally by far the most common issue that people hit when you're doing this. So make sure you change this, change to vector 3. Okay? So I just wanted to point that out since everybody's hitting that. Almost. Fix that. See everybody on Monday. But again, I'm around for a few minutes if you want to ask some questions. I'll just be like, wow, so, and the dependency happens when you're not. I do need to do this. So wait, do you guys want to specifically because that's why I have to train it by 6 today. It's not done by 6 on one. Yes. So So these functions all kind of make the class behave in some special way. So like the double underscore sub and double underscore add, they allow you to make it so that plus for operator overloading and minus work. Whereas this is just some method that you have to do. So notice up here, look at the differences in these. So up here, the add method gets called implicitly when you do view plus v. So it's like this notation. Whereas all the methods that don't have the double underscores, they just get called in the normal way. It's just v dot v or v dot whatever. So they're special. Oh, so you could just there's no special underscore methods for cross product. There could be, but there isn't. There's no special notation for it. So what you would do is you just make a method like length, which you could call cross product. Yeah. So for example, this person made a method cross, which is so notice they just call it cross. You can call it whatever you want. There's no special underscore type method for that. If you look online, there's like a big list in the Python documentation of special double underscore methods. It's kind of like well, in other languages you use like operator plus. Yep.
So the homework, if I had done it, or I had done it last night, but it's no longer there, so I just need to retype it out.
Or find it. Hopefully it'll be in the time travel,
Okay.
and then you can just
It
copy
seemed
and
like it was
paste
one
it.
of the first questions in time travel. So
The entire thing.
yeah.
Did you click on load everything?
Maybe not. I'll try that.
You can also check the snapshots, but you have to just type it in.
Okay, no problem.
It will be better. It'll be good for you. You'll learn even better.
Thank
It
you.
should be easy the second time around.
Yeah, hopefully.
Yeah, very, very bad. Yes.
Okay. Have a good day.
Yep. No, I didn't have a good day. I have a good day. Yes.
So, for the last is that, are those like, I'm just not kind
So, yeah. But notice they should be actual objects. So like when you say, let's just do one. So give Python object that can't be the key of a dictionary. So you said list. Okay, so just give an actual list, like square brackets 1, 2. And then that would do it. So you could say, in a list, for example, list of, for example, you want to give an explicit object. So like, don't just say an abstract or list. It needs to be an actual object. Yeah, and that's why it says your answer should consist of objects of. So that type of object.
Oh, it's because
So you can't get yeah.
So that's
Nope.
put in the underlines.
No, because the thing where it says type of objects are different. If you do type on a couple of different lists, every single one's going to output list of the type of the list.
So you need to have.
So you can't get
You need
that.
to either include them in your call or just take them
You
out.
could do a list and a tuple, and then you might have to think about it.
Yeah, the lines are for Python. So that should work.
You do a set. Yeah, it's a question.
Yeah, it's for doing like more
Okay.
actions like adding.
Yep, it's an unsolved problem. So at first, nobody knows. Like literally, no one in the world knows whether or not
That's a real.
they're infinitely big.
Yeah, because it would just be X usually. So yeah. Confused.
Yeah, that's well. You might want to choose that. Which is more convincing to you?
Oh, because you take your run where you initialized vector.
You have to make a choice. I mean, obviously, I can't say that. Nobody can say whether you made the right choice or not. But first, I mean, you have to say what you think. So you have to make a choice, and then you can say, I think this because there's two arguments, one for it and one against. I think the one for it, or I think the one against is more convincing. Yeah.
Thank you.
Yep.
That's what it's looking at.
So there's no class after us.
So, for our first one, shouldn't they have written objects? Or should they have written objects?
Well, let's see. In 1A.
One.
So 1B. I guess so. Yeah. Well, same types, you're right. Yeah.
Or number 3. Okay, if I create my stuff like this, like I know there's different process of curly braces that on the set itself.
Nope, it says set comprehensions. So you really have to, you can't use a for loop. You have to, you can do you can convert these to for loop. Well, look, let's see. So like in this one, you should be able to do like, so and for and in. If and want so I did that.
Oh, so you're not. Okay.
That's what this means when it says using set comprehensions. So you really have to do that. Set, not with the for. We should all formally convert to set comprehensions previously. Don't like, you don't have to eliminate the for loop. It's nice to see both of them, but do include this. Because the grading guidelines will say this.
Right. And then for C, that's every
Yeah, it turns out it's pretty easy.
Oh yeah, so this one. So 5 pieces of right code is how many of those integer primes?
Yep.
So then, does that mean you want us to take the same
Yep.
in this and not create a new one?
I don't care if you create it or not, but the key thing is at the end you have, that's right, at the end you have the number of good ones. Okay, cool. Sure. So it's auto inputs.
Yeah.
And it could be a plugin in auto indent code, or it could be something in your code that you could have maybe made mistakes somewhere. And when it tries to analyze this syntax, it's thinking that you need for it to be indented. I'm going to clear this white space and see what happens. The red indicates white space, the trailing white space. Usually that sort of thing would happen when there's like, maybe when there's something actually wrong with the input. That doesn't look like there's anything. They assume it's just a value, it's fine.
Right. Yeah, it's been working.
So one thing is, whoa, it could actually be that it's above us. Like, yeah, so there's no problem in this particular cell, but the auto indentation doesn't get reset between cells. I wish it did. Maybe I should change it so it does, but it doesn't. So it could be something way up here. I think though we could probably, no, I guess. I think that one is, no, that didn't reset it. So there's something somewhere above that is confusing the other indentation.
Okay.
I don't know where.
So it should just be a one-time issue.
Yeah, of course. I wonder if Trace would do this. So we kind of went to the bottom of this. I'm just going to make a copy of the worksheet so it's in place in the share project. The pin worksheet. Nobody will notice it. Then, so I think by so I can at least look into it later. Cool. Okay, yeah. And any other issues?
No.
Okay.
All right. Thank you.
this in vector 3.
Oh, yeah. Oh.
I think the mistake everybody makes is to just I advanced it because it's so complex. And then you did it up.
Oh.
Yeah. I didn't realize how common that. Okay, now I can see what the repper, so you have only 2% S's here, and 3 of those.
Oh.
So the second most common is.
But is it kind of just a string or?
Yeah, but you have to, the number of things here has to match up with the number of things there.
Oh, okay. Oh, okay.
Of course.
Okay, thank you.
Sure.
Another question.
Everybody makes the same mistake.
Oh, yeah.
It's like all the exact same mistake, every single person.
The homework, I'm not sure. Because I said that we can use the is prime here
Yes.
to check the
Sure.
So
That's
does
right.
that mean like we can use this method like every other problem?
Sure. Yeah, you're welcome to use this one. Don't use, there's a function called like Fibonacci number built into Sage 2. The Fibonacci range. Like that's all in Sage. You don't use that.
Okay.
Don't use that at least.
Number one. I'm not sure that if I just like if I did that way, that was kind of
suspicious. Remember what? Oh, wait, I'll be okay. Yeah. I think it's, yeah, because they don't have different
But
types.
it's
kind of cheesy. You can challenge yourself more if you want. But
I'm not sure.
technically that's correct.
Okay, but I'm not sure what that any other types
Okay,
of
well, that will be technically correct.
but yeah, but I know this is not very creative.
It's not very creative, but it's correct. You could do something with adding strings, see what happens.
Okay.
Like, because you can add two strings together and then concatenates them. You can see whether, what happens there. You could have a list, you could add lists together and see whether equals this. Well, shouldn't actually. Almost never is. This one's kind of funny because I think the reason that they're not equal is because, like, in some cases in Python itself, I just want to copy this one. You can delete this afterwards. I'm just curious. Oh. Yeah, I need to make this.
Oh.
It'll, like, once my cursor's there.
Okay.
Just curious if I do percent Python. What is that? It says true.
Oh.
Isn't that interesting? So the reason in Sage all the integers are, we have our own integer type that we wrote. Like we wrote our own class for integer so that you can do like number.factor. Python has its own built-in integers, and when they're small, there's only one 9. Like anytime you have something that includes 9, it gives you the same Python object back. So that's why the equals and is are the same. Whereas with Sage they're not. So it's not kind of subtle.
Okay.
It's pretty subtle. And it's for efficiency purposes, Python itself, all small integers, they're just they're represented differently. There actually exists just there's some internal clever optimizations in the Python interpreter itself, which is why these get different answers. Basically, why that's true false versus that's true.
So actually, I mean,
That's interesting.
This that work, right?
It's fine. No. I'm not. Your answer is 100% correct.
Oh, okay.
If you had given this in Python rather than in Sage, it would not be correct.
Okay, but it's
For technical
asking,
reasons.
but it's asking in Python, right?
I guess it is actually. Well, no, I mean Sage is part of Python, so like if you use integers in Python, not the version that is in Sage, then it wouldn't work. But the Sage integers are still in the world of Python. I mean, it's still Python language. It's just
Okay.
it's kind of silly. Any other questions? One thing with 6b, make sure that you give actual objects. Go ahead and like that.
Oh yeah.
Whoa, what is yours? Jeez. That's not horrible. Associated dictionary, standard keywords, collection class. Associated. Come on, people. Associations. NS mutable dictionary. There's a typo in objection C.
Oh yeah.
Dictionaries and history. And variables are compound variables and graphs. Jeez. Is there a Wikipedia page about associated
Yes.
variables?
Is it okay with
JavaScript? Yeah, that's fine. It's just funny.
Yeah.
So, you feel like you learned a lot from doing the assignment?
I think so. Yes. Yeah.
Do you feel like you're learning stuff in the class the way I'm organizing it with talking and then you do stuff?
Yeah. Yeah.
Do you fall asleep during class?
Yeah. But it's kind of like.
Wait, do you fall asleep during class?
It's like kind of like just, so many things to learn that actually we don't have enough time to catch it everything.
Yeah. Oh yeah, definitely.
Yeah, because of the run compliance.
Yeah. Yep. There's a way to get it directly.
Great stack overflow answer.
Yeah.
And all the solutions. So
Yeah. It's the non-iterative.
great. There's no question we can ask for not.
This would have a problem because we're sufficiently large and would probably overflow and give a wrong answer.
It's not a.
Yeah, but yeah, it would be a floating point number and it would overflow. However, in Sage, if you just deleted the line that says from math import square root and then did that, it would probably work perfectly and never overflow. Because in Sage, you have arbitrary precision, numbers, square roots, and simplification of symbolic expressions. But you might have to throw in full simplifiers. Try that in Sage, but without that line. So it uses the built-in square root Sage, which is exact. It would be incredibly inefficient, but it should work without any, like it should work for arbitrary things. Yeah, you're creating guidelines, but you really get this because it's clear from people's questions that our problems are somewhat ambiguous. You try to full simplify it.
John, who made that question that NQ plus 1 is
That was a typo.
that thing was freaking empty. I
No.
was like,
It's not empty.
Okay, let's go. Simple.
So put have full simplify at the end.
Yeah.
Then it makes a huge, massive, terrible symbolic expression, and then it simplifies it. Technically will work. I think I made it, but it's not empty.
wait, NQ plus 1 is congruent to 3 1.
Everything is congruent to everything mod 1. It's stupid. But any two integers are congruent mod 1. So it's actually just all the numbers in that range.
Wait.
So the definition of congruent mod 1 is that A and B are congruent mod 1 if the difference of A and B is divisible by 1. Everything is divisible by 1. So if you divide by 1, the remainder is 0. That's what divisible means. Yes.
Wait, what do you want that?
But I'm going to make it do on Monday.
What do you mean?
Well, I didn't mean to say congruent to something mod 1. It's kind of stupid. It shows congruent. I think it was supposed to be n cubed plus 1 is congruent to something mod 3. I got the
Oh.
mod thing reversed.
Okay.
Mod, it shouldn't be mod 1.
Because basically, if you divide something by 1, if you mod 1,
Yeah.
it's always going to be 0, right?
So,
Anything mod 1.
so A and then a congruent symbol B mod n doesn't mean that A mod n equals, well, doesn't mean that A percent sign N is the B thing.
Okay.
That's not what it means.
Okay.
That's the problem.
Oh, got it.
That's like the computer programmers view of what log means, or what congruence means. But it's not that. It's like A congruent to B means that if you take A minus B, it's divisible by N.
It's divisible by N. Oh.
And divisible by 1 in the case of integers is kind of always kind of satisfied. It's just a trivial. For real numbers, it's interesting.
What kind of functions have you been?
Well, just, I think that there's a huge amount of questions. I mean, I pasted some of them into the chat. I feel like there's a lot of questions that our homework wasn't sufficiently clear, given how many questions people asked. So we'll have to be very clear in the guidelines. And those are just some. The peer grading thing, by the way, has a box where you'll be able to paste in guidelines, and you automatically put in the copies of the assignment.
Most of the questions I've done on the actual questions.
Maybe the ambiguity already got resolved in the chats.
Maybe.
You can do some spot checking. Go down there to see what. Actually, it's actually kind of cool. When you make the grading guidelines, just like look at some assignments, and then because we don't. Well, actually, we can collect everything first. You don't have to make the guidelines before we collect the assignments. We can do that afterwards. I'm going to do the question on Monday. Okay, officially. How did you change it? Because if you just change it in that one place, it doesn't really have that. It just means that we see it in that place. Yeah, they won't see it. That's fine. We should. Can you send out a message to the list? For the people who might not have been. Well, there's 2 points to make. One you have to be done by Monday, and 2 you do have to do it. Even if you already did it and then seriously got it. That was one guy's question as he left. He's like, if it seemed to partly mysteriously vanish, do I just not have to do it? I'm like, it'll be good for you to redo it. So when did you do that? So you know, like when you save the green button turns disabled, it wasn't doing that. Because it wasn't saving. But it also wasn't necessarily like really viciously popping up every single time. And you keep saving, but it actually wasn't saving.
Why never press that save button?
There's 2 notions to save, by the way. As you're typing, it's supposed to be saving everything as a list of patches to the database, which has nothing to do with the files in the file system or the project at all. Even if the project is off, it's doing that. And then the second level of save is actually saving to the file system. And
you do that by pressing save.
Yep. And that happens automatically every 30 seconds.
Oh, yeah.
So auto saves. So there's no indicator at all in the graphical interface that it saved stuff to the database or not. And there should be like a, because that's a super important thing, that should be like really, really clear in the interface. I'm gonna add that.
Oh, like Google Drive.
Yeah.
That's
Exactly.
saved.
Yeah, exactly. Like that it's really been saved and that it's safe to turn on your computer. But then there's another version of save, which is that it's actually saved to disk in 2 different things. So it needs to say that it's saved off of your computer and then also saved to this. Even if some of your homework may have disappeared, you do have to have, you actually have to do your homework. Just really do. Maybe that should be obvious to most people, but I did get that question. Yeah, you covered that. Don't even try it. Maybe it's implicit.
You don't have to really drop a homework. You don't really have to.
You want a great
Just like, okay, don't say that. I think of people like computers sometimes. And for a computer, you have to be very explicit.
Right.
Yes, indeed, you have to compile this code for me. Oh, it didn't work. So yes, you have to compile it for me.
Yeah.
I do want to remind them of some things like problem for you. You're supposed to use it.
Yeah.
Please do. Yeah, I had a couple people come and ask me, like, what do you think of my solution? I'm like, well, I think you don't want to use that one, right? And they're like, oh yeah, because user recursion. I'm like, yeah. He's like, that's the one I know. I'm like, no, look it up on Stack Overflow.
Yeah.
It's a great answer.
Wait, are not everyone actually using that?
Yeah. Yeah.
I think I just made the.
If you do request, yeah. Well, I don't know. If you use recursion, it's wrong.
Okay.
Because if you put in a number above 1,000, it'll just crash. Because Python is empty with recurse more than 1,000.
Oh.
Yeah. There's a stack of it in Python.
So you should. I mean, I can't use the for loop.
For loop's a good idea. Yep.
In the range of the number that we're not number.
Does it talk about the stack problem in the Stack Overflow question? It should, because it's actually literally a Stack Overflow. Perfectly. That'd be ironic. The Stack Overflow closed.
Wait, so what is it?
But there's already a hint here, so like.
What is the problem with Python and recursion and stack range?
Well, just so in some languages you can write recursive functions that recurse arbitrarily deeply, and in other languages you can't.
And Python's one of them.
Yep. Python maintains a complicated amount of state about each step in the stack, and it takes a lot of memory. And if you have something that recurses like 100,000 times deep, then in some languages that's just like doing a for loop 100,000 times. There's no business. Python, it maintains this, like for every single step, it maintains this huge amount of information about what happened.
Oh.
And so it just like uses a lot of memory. And if you were to recurse, that's what the stack trace looks like. So you recurse down 100,000 steps,
Right.
and then raise it up. Yeah, 100,000 things in a row. All that information's there. Right, so should we go meet? Yeah. Let's just meet on the office grounds first. But
Hey William, are we
Yes.
gonna start having meetings with like all the you guys?
no, we could. I don't know. I haven't done that in a while. We could actually. Could be useful.
Thank you.
Yes, you're welcome. See you later. I hope you learned some Python.
Python week is finished. Woo!
Cool. There's lots of.
Like once a month.
Wow, there's tons and tons and tons of solutions in the shared worksheet. That's really cool.
No more Python. On to